The 8th grade notes for elimination method or the canceling out method begin with an explanation. We're continuing to work through that process of solving a system of equations. System of equations for us right now is two equations in the same problem with two variables, x and y. And we're solving for x and y. X and y solutions here are the values that we can plug into both equations at the same time to make the left side equal the right side. Now, we've already done this a couple of different ways. What we've done so far is we did the graphing method. In the graphing method, we graphed both equations and we found the point at which they overlapped. Of course, as we said many times during that instruction, the problem is if the graph doesn't go through at grid markers, if it doesn't go through at nice integer values like 1, 2, or -3, -5, sometimes it's really hard to tell what those points are. And that method really depends on your precision, drawing really nice lines with the ruler and making sure we get the point of overlap really nicely. So then we switched and we did substitution method. Substitution method is a method that requires calculation. And as you saw from that instruction, substitution method can be kind of painful depending on how much work we have to do. So now here's this thing called elimination method. And people tend to prefer the elimination method because the work that goes with it tends to look and tends to sometimes even be shorter. So let's talk about what we're going to do here. When we're talking about elimination method, all right, we're still talking about solving a system of equations. All right, so you're still going to be finding a solution x, y, as you see illustrated there underneath the how-to in step 6. What are we going to do? Well, we're going to line up the terms in equation number 1 and equation number 2, and they can be in any order. So somehow you want to see vertical alignment of the x values, vertical alignment of the y values, and vertical alignment of the constants or lonesome numbers. Which way you do that is up to you. If you have x's first, and then the constants, and then the equal sign, and then a y, that's fine. If you have y's first, then x's second, and then equal sign, and then a number, that's fine. What you're going to tend to see me doing a lot of here in the instruction is standard form, with the x's first, the y's second, the equal sign, and then the constant, the lonesome number. It's not that there's anything preferential about it, it's just a form of a line that we recognize and we use quite often. Now, at this point, what you're going to be looking to do is you're going to be looking for either the x values or the y values, as I'm talking about there in step 2, to be like in terms of their value, but opposite in terms of signage. So you want them both to somehow say 3x, for instance, or you want them both to say 7y, for instance, or you want them both to say -308x. Whatever the case may be, you want those values to be the same. But what you want here is you want them to have opposite signage. So one to have plus in front, or one to have minus, and the other to have minus in front, one to have positive in front, one to have negative in front, however you want to look at it. Once you do that, and you may have to manipulate an equation to do that, which we'll show you here later on in the examples, then what you're going to do is you're going to add the two equations vertically. And that's where the elimination method stuff happens. When you add vertically, once you have those like values in terms of the x's and the y's, with the opposite signage, something's going to disappear. Something's going to cancel out. It's going to leave you one variable and your constant. And once you do that, you're just going to solve the equation. You're going to solve the equation for whatever variable's left, x or y. And after you do that, what they're talking about there in the remaining steps is step 5 and step 6, you're going to have an answer for one of those variables. Again, x or y. You're going to plug that into one of your two original equations and find the other value. So that last step should sound familiar because that last step isn't any different than substitution method. All right, that's exactly what we did. We found x, we plugged it in for x, and we found y. If we found y, we plugged it in for y, and we found x. That's exactly what you're doing here. And once you do that, you'll have your x, you'll have your y, and you can write your solution x, y. So let's go ahead and take a look at this in some examples here.